So, all right, we can move this out of the way. 24 questions coming at you tomorrow. This first section here, which includes all of our variable rules, okay, our exponent rules, there's going to be a couple of these. Okay, so not a ton, but enough that we're going to have to think about it. But again, also a reminder from what we talked about yesterday. When we're looking at these, we always look to see, are there parentheses first? Well, in this case, there's not. Are there any negative exponents? Oh, but that there are. So, I'm going to make this a fraction. And anything that has a negative exponent, but some of you are like, well, wait a minute. I only see two things that have exponents. What do I do with the other stuff? Well, the other stuff, remember, has an exponent of 1 if I don't see it. So, it looks like a lot of this is going to get to stay right where it is. The 4 stays. The y to the first stays. The x to the fourth stays. Wow, most of this stays. 3. Y to the first. The only thing that's going to flip is that x to the negative first. So once we get that flipped, now we get into all of our multiplying and dividing stuff. But we do have a situation that's a little different than what we saw yesterday.
There's a lot of late kids coming in.
Alrighty. So as we go with this, what we're going to do is we're going to just clean up what we see up here in the numerator first. Sure, it takes me one extra step, but it helps it where I'm not going to get as much trouble rolling here. So, 4 times 3. Notice I didn't say 4 plus 3. Coefficients do not run by exponent rules. And then I notice I've got 2 y terms up here. When we're multiplying, we add the exponents. So now I take one more look because I'm like, I might be done. Okay, there's only one y term. Oh, I still see multiple x terms, so I'm not done. I'm dividing here, which is subtract. Bigger minus smaller. So I haven't touched the 12. I haven't touched the y squared. 4 minus 1 is 3. Bigger exponents up top. If you want to put a 1 in the bottom, you can. It's not necessary, but you could, and I'm set. But again, step by step, just work your way through it. If you get stuck, leave it, go to something else, come back. When I get to 3, no parentheses. I see negative exponents, though. So let's work side to side here. So I'm going to leave everything alone except the only thing I see that has a negative exponent, which is this y to the negative 1. That's going to flip down to the bottom. And similarly to what we did on the last one, I'm going to simplify things in pieces. So at first here, I'm just going to look at the numerator. I see my coefficients. 3 times 2 is 6. Again, they're not exponents. Don't use the exponent rules. I see 2 x terms that I'm multiplying. So 3 plus 3 is 6. And my y to the third. Then we just roll that over. So I look and I'm like, okay, I got a 4. I don't have any other x terms. I'll write that in. But I've got y squared times y to the first. So I add those up. So once I get there, now I go back, and this may be where some of you go to a calculator. Because that 6 over 4, still coefficients, still not going to subtract them. Wouldn't work. So I need to try and simplify that down as best I can. Probably the quickest way to do it, and the way to make sure we do it so it doesn't do anything too funky to us here. 6 divided by 4, not 1.5. Math enters 3 over 2. So I get my 3 over 2. So, 3 over 2. Six over 3, again, I'm dividing, so I subtract. 6 minus 3 is 3, bigger exponents on top. Then I get to the one that can cause a problem. Y's. 3 minus 3 is 0. Means they're gone. Doesn't mean I put y to the first somewhere. Anything like that. I'm just finished. So that one's set. Okay, so those can take a little bit of time, but nothing too bad. So then I get down to 5. Now it's the same stuff going on, except now I have a couple of fractions in here. Put those ones in there. So the 2 gets left alone. U gets flipped. V gets left alone. 4 gets left alone. U to the 1/2 gets flipped, because I didn't have any parentheses. So now I'm doing my multiplying, dividing, and things like that. 2 over 4, again, is not 4 over 2. Okay? If I put that in my calculator, I get a 1/2. So I get that simplified. There are no other v's. Keep my v squared in there. And then here, now I got to be a little more careful. Subtracting. 1 minus 1/2 is 1/2. Bigger exponents in the denominator. That's where my 1/2 is going to go. No negative exponents. No multiple terms with the same variable. That's how I know when I'm done. Okay, so there's 2 of those type. Yeah. Okay. Because here, when I reduced down my 2 over 4, it was 1 over 2. So I just put down the fraction that I got for that one. Yep, the second one I just simplified. There was no other v's for me to combine with. And then I did my normal subtracting since I'm dividing here. I just did my 1 minus 1/2. And of course, I'm not going to use 0.5. So it just let me know that the answer is 1/2. And I just put it where that bigger exponent is. 1's bigger than 1/2, so that's how that ended up down below. Good questions. So 2 of those. We get to the next section here. There's going to be 2 of these, just like there are on here. Write the expression in radical form. And we talked yesterday about it's exponent over radical. So, get this. I put my base in parentheses, whatever's down there. And then that's going to be my exponent. That's going to be my root. And that's it. Nothing to solve. Nothing to simplify. Just plugging them into the right places. And the nice thing with these 2 sections are you can kind of play them off each other. So when I get down here, what I'm going to do is I'm going to go, okay, here's my base. Exponent over root, just like it was over here. Now here's my question though. There's my exponent. What's my root number when I don't see one? 2. Nicely done. Okay, exponents are 1 if I don't see them. Roots are 2. So we got that. Not too shabby, not too shabby. So then we get back to factoring. And again, your tan sheet is fair game to use tomorrow. If that's something that helps you out. Here's your multiplication chart on the back. But we're always going to check first to see if there's something in common. Is there something that divides in as far as a coefficient, as far as a variable goes? Anything go into all 3 of these terms? 2. So if I divide that 2 out, 2 divided by 2 just gives me p squared. 4 divided by 2 is 2. 16 divided by 2 is 8. But I still need to look to see if I can factor what's inside the parentheses. And notice the 2 is not going away. So once I get to here, I am fortunate because there's no number in front of my p squared that it's just going to be a diamond. Multiply to a negative, which means we have 1 of each sign. Add to a positive, which means the positive number will be bigger. So 2 numbers that multiply to 8 that are 2 apart, 4 and 2. Okay, but I've got to get that out of there. If you went to slide and divide on this one, it's not going to work out correctly. We kind of saw that a little bit yesterday. Always got to get that common term out before I do any of the other factoring terms. Otherwise, our answer is going to get a little crazy here. All right, more factoring coming. Ew. That doesn't look like fun. All right, let's see here. Let's see if something's going to go in before we get too far here. Let's try something small. Let's try 2. Is 2 going to get me through on all of these? Bless you. Yes, and here's the other thing I take note of here. If I look at my answers, I don't see another number that's going to divide into all 3 of those. So it's not like there's a bigger number I could take. So if I take a 2, that leaves me with 7k squared and minus 40k and minus 12. So I still am going to need to guess and check, slide and divide here. So since many of you are kind of in my slide and divide mode, I'm just going to remind myself this is sliding over, but I'm going to do my work to the side here. So k squared minus 40k minus 84. Ooh, this might take a minute. We're like, okay, what do we know? We know that since this is a negative, there's going to be one positive and one negative. Since it adds to a negative, we know that the bigger number is going to be the negative. But here's my deal. I got to figure out what goes into 84, because that's not one we do every day. So as we've spoken of at other times, I would suggest starting with small numbers and just seeing, okay, so 2 and 42. Ooh, wait a minute. 2 and 42 are 40 apart. This might work. If I put 42 here, and I put 2 here, 2 minus 42 is negative 40. 2 times negative 42. Hey, sweet. Okay, I got it the first time. Won't happen every time, but that's nice. But remember, that's not the end of my factoring. The number that we slid still has to divide. So 2 divided by 7, I got a decimal. No good. Just goes to 2 over 7. So that's going to go back in front. So here, I would have 7k plus 2. And then 42 divided by 7 is 6. That came out nice. So it's just k minus 6. And I'm done. But you've got to remember the 2 still gets put in your answer part, even though I'm not necessarily working with it as I go through the rest of them. Okay? Lots of little detail stuff. And we get to see that again on 15, except the fact that there's nothing that divides into all 3 of those. So no extra factor to play with. We're just going to slide on down here and get to work. So as we do that, all right, here we go. We get to play with 84 again. So we've got 1 plus and 1 minus again, which means they're going to be 17 apart. So let me bust my list back out here. So I know 2 and 42, but they're not 17 apart. 84 divided by 3. 3 and 28. Not 17 apart, but I'm getting closer. 4. 4 and 21. 4 and 21 are 17 apart. This sign tells me that 21 will be bigger. But again, don't forget about your divide part. If it goes in nice, that's great. If it doesn't go in so nice, got the same fraction back. And I'm good. So I may have to play with the calculator a little bit, but it's not going to be the end of the world as far as that goes. So again, the factoring, what did I have on there? There's going to be 4 different types of factoring questions. So be ready. It can be anything from just taking out a common term to slide and divide to just a diamond. Who knows? All right. Graph the equation. Tell the vertex, domain, and range. There's going to be a couple of these. Now remember, with our form, if there's something inside the absolute value, that's my h value. Well, there's nothing there. So that part of my vertex is 0. I didn't move left or right. Okay? My k is the number on the outside. That's my y value. So that gets me my 4. So don't move left or right any. Move up 4. There's my vertex. And then I notice my a value is 3, which tells me I'm going to open up. So I'm going to go up 3. I'm a little off. That's okay. And over 1. In both directions. But don't just stop there. Don't be content. Give you a pat on the back. Remember with these, domain's the easy part. Always infinite. Range is going to go along with whatever your up or down shift is. So here, my bottom is at 4, and it goes up forever, because we go bottom to top with those. And we just keep seeing as we do these. Okay, there's patterns to all of this. Because in a minute, we're going to see that exact same form, except it's going to be with a radical. So again, nothing too bad. So I flip over. We got one more of these. Okay, I need some help this time. What's my vertex going to be on this one? Okay, 1, the opposite of h. So the opposite of -1 is 1. And there is no plus or minus, so it's 0. Make my point. My a value is -2. The negative tells me that my v is going to open downward. So down 2 and over 1 each direction. I got room. I think I'm going to make one more set of dots. Get that set. Again, domain, easiest point you'll have on the test, because it's always the same, even if I open up or down. And my range, again, goes bottom. Notice where your arrows are going. If they're going down, the bottom is first. And I didn't have any plus minus out here. I didn't have any up or down. So that's going to be 0. There would be, if you wanted to double check on the calculator. Good question. This is one where we got some button presses going, and this is something I won't do step by step with people tomorrow. But if you wanted to, if you go to math and over to num. Now, in this case, I have a number in front, so let me do that first. So -2. Once I get to the absolute value part, if I hit math, an arrow over to num. ABS stands for absolute value. So I type that in, and some of your calculators, it may put a parenthesis there in the word abs. Some of you, it may be the bars like this. And then if you go ahead and plug in your values, you can either look at the picture, which then would look like yours, or you could even, once you know where your vertex is, because again, the vertex would be the center of my chart. Whoops, I went a little too far. And I would know I did that right because I would see symmetry. Here's the center, and I see the exact same numbers above and below. So it's a nice way to double check if you've got some extra time or you'd like to do that. Good question. Okay, radical ones, same idea working. There's our equation that seems to pop up everywhere with our shifts. So we're going to be looking at our mother graphs here. And again, our mother graph is just the square root of x, and if there's a number in front, we deal with that. But this time there's not. So this is going to be the same as it is here. So I plot those points. Again, we're just making them little. We're just using them as a reference. But now I've got to figure out what my shifts are. So it looks like we've got left 5. Again, you need to know this part. And up 1. You know that by practicing it. So each of those 4 points I made, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 1. Just connect the dots on the one that actually is the graph. And again, we're going to see that connection that we saw yesterday between domain and range in your shifts. I move left and right on the x-axis. So left 5 means that my domain starts at -5. And I also can do that visually once I have it graphed and say, okay, where's that on the x-axis? -5. Any up or down shifts are going to change your range. Again, take that point back to the y-axis. It's 1, but I also had an up 1 shift. They both will get me there. But you've got to have a grip on your parent graph to be able to do this well. Because otherwise it kind of can get chaotic. Just saying. Let's see, what else we got? All right, now we go calculatoring. Solve each equation on the graphic calculator. Isolate your radicals first. There can be one on each side, as you see here. That's not a problem. And again, once we're here, to get your radical, it's second and x squared. 15 minus, whoa. Let's get out of there. Let's try that again. Technology is great until it goes haywire. Okay, 15 minus x. And then I'm going to arrow down and I'm going to type in the other one. Second x squared. 3x minus 13. Now, if I want to take a look at the picture first, it might help me see where I think the intersection is going to be. So let's see. 1, 2, 3, 4, 5, 6. I don't know. Maybe somewhere around 7. So let's look at the table. And as I start to go down the columns here a bit, what I'm looking for are two y values that are the same. Now, it doesn't mean they're going to be whole numbers. So when I get around 7, I notice, hey, those decimals are the same. Is that the answer, though? No. The answer is the x value that's there. And I'm done. And that's basically all there is to it. So for any of these that we do, we get those cleared out. We type in what's there. Sometimes it'll just be a plain old number. That's okay. So again, there's where it looks like they cross. And it looks like it's about 2, maybe 3, somewhere in there. Let's see. Y values the same. Whatever x is my answer. And occasionally you may even run into one where there isn't a crossover. You have no solution. We've seen those before too. So there'll be a couple of those. Standard form of a circle. Again, if you forget, remember on the test, the actual form is going to be on the next section. So if you forget, that should give you a good hint. There's my h and my k. So when I'm going to write these, x opposite of h, so plus 9 squared, plus y opposite of k, opposite of positive 9 is negative 9, squared, equals my radius squared. 9 squared is not 18. Okay? 9 squared is 9 times 9, or 81. Okay, if you're going to do all the good stuff, remembering that here, let's not blow it when we get to the radius. Circles, graphing. Get all the information we need. Again, you can kind of use what you had above to help you. It's x opposite of h. Switch my sign. Y opposite of k. Switch my sign. And this is what my radius squared is, which means I have to take the square root of it. Plot my point. -3, 3. Radius of 2 just means we're going to go 2 up, 2 left, 2 down, 2 right. Draw my circle in. So lots of things interconnect with these. If you get a little bit of practice, it's usually not too bad of a deal. She's like, wait. Opposite, opposite. Because in the regular formula, it's opposite of H and opposite of K. So, yep, whatever's in the parentheses, we want the opposites on both. And then piecewise, we started to talk yesterday about the importance of understanding that when we do these, that tells me where my line starts, period. So, when I go to start looking at numbers, I know my first x value is going to be 2. Since it's less than or equal to, I know it's going to be a closed circle. And since I know it's less than, if I start at 2, less than goes left. 1, 0. And I'm going to plug those into the calculator. Now, could I put this into y equals and then look at the chart? I could. I think you're capable of doing it without, but if you want to do that, you can. Negative 2 times 2 is negative 4. Plus 1 is negative 3. Negative 2 times 1 is negative 2. Plus 1 is negative 1. Negative 2 times 0 is 0. Plus 1 is 1. So I've got my 3 points that I need now, including 2, negative 3, which I know is my first point. So I'll make that bigger. 1, negative 1, 0, 1. Start at the big dot. Connect the dots. And I do that same thing with my second one. I'm starting at 2 because the inequality tells me that. Open circle because it's not or equal to. If it's greater than 2, greater than means we're adding to it. We're going to the right. So 2, 3, 4. And now we just substitute these into the expression. 5 times 2 is 10. Minus 4 is 6. 5 times 3, ooh, this is going to get big, is 15. Minus 4 is 11. Holy cow. 5 times 4 is 20. Minus 4 is 16. We're going to be a little off the graph here. So 2, 2, 3, 4, 5, 6, open circle. 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, oh dear. 9, 10, 11, and I'm not even going to try 416. So as you can even see on the review, occasionally we may get a little off whack here, but if we're doing everything right, that's okay. When we get down to the bottom, if I can see the point on the graph, go ahead and try to use the graph. Otherwise, I look at this, and that's telling me my x value is negative 4 less than 2. Yeah. So I'm going to plug the negative 4 into that first expression. I can do it on the calculator then, or negative times negative is positive 8, plus 1 is 9. Get my answer. For 8, is 8 less than or equal to 2? No. Is 8 greater than 2? Yup. Plug the 8 in. 5 times 8 minus 4. Again, if you're doing things correctly and you're kind of looking it over, don't worry if the numbers are big. F of 2. Is 2 less than 2? No, but is 2 equal to 2? Yes. So negative 2, plug that in there. Negative 4 plus 1 is negative 3. And I could actually see that if I looked at my graph. But again, use the chart. Draw a number line if you have to. It's okay. Finally. All right, functions. Reminder. Okay, domain and range. I have to pay attention. The two we did yesterday, both were dots on the end. Okay, so we ended up with numbers for everything. This time, I noticed there's arrows on the end. That changes things because now this is going to keep going and this is going to keep going. Well, how far is it going? Far enough that it goes forever to the left, forever to the right. Now range, I got to think a little more. It does go forever down. I'd be with you on that. But does it go forever up? No. It seems to stop right here at -1, -2. So just because I see arrows doesn't mean everything's going to be infinity, but a lot of it will be. My vertical line test to test for my function. Good. Still at 1 point. Okay, that one's a function, so I'm okay there. Again, with domain and range, I see it goes forever to the right. Okay. So I know that positive infinity will be on the right side. Does it go forever to the left? No. It comes to here and stops. 1, 2, 3, 4, 5. And order matters here. I can't put infinity to -5. It goes left to right, just like when you read a book. Okay, my range, I go down forever. All right. Oh, I'm going to go up forever. Okay. So those kind of switched around. And then finally, when I go to do my vertical line test, I run into a problem. Because you'll notice right here, and here, my graph is going through my vertical line. If it ever goes through more than once at any point, like here where it goes 2, that's not going to be a function. Okay? So again, the test tomorrow is going to be about 60% of this size. So when we can, kind of buzz through here in less than, about half an hour with our delays, this is doable, okay? But you've got to be ready. Grab another review. Go back and do the homework maybe if there were some things you had some issues on. Watch this again tonight. Somebody watched again last night because the views were up to like 8 by last night, which is good. Some of you are taking advantage of that. But otherwise, be ready when you roll in tomorrow and we'll be testing.